Okay, we're going to talk today about what happens when the one of your terms is a fraction. So from yesterday, what we said was that these bases, all right, there's a way to write these bases so that they're the same. So like, just because it's on the same screen, if we're looking at this 3 and this 27, right, 27 can be written as 3 to the third power. Now we have the same base, right? And that's what we're trying to do. So to remember, hopefully, how could I rewrite 7 and 1/7 with the same base? Well, hopefully you remember 1/7. If I have 7 in the bottom of my fraction, I can rewrite it with a negative exponent, right? Hopefully we know how to go back and forth between 1/7 and 7, okay? And that's really the new stuff for today. Like, that's it. Okay, now that we have the same base here and here, we can keep it moving there. Real quick before we keep going though, again, what you're looking to do is have the same base. Once you have the same base, you can get rid of the bases and you just have the exponents set equal to each other, okay? So now if I just keep, let's see, here we go. Yep, if I keep going, right, I get 4x equals -12, x equals -3. Just to check real quick, does 7 to the 4 times -3 plus 11 equal 1/7? That is 7 to the -12 plus 11 equals 1/7. Yes, it does, right? 7 to the -1 equals 1/7. This is my answer. Okay, again, I see a fraction, right? We just want to remember, can I rewrite a fraction as a whole number with a negative exponent, right? So on this side, just to the -1, right? And then on the left side, how can I write 81 as base 3? Well, that's 3 to the 4th. And again, I would have the graphing calculator handy for this lesson, okay, or for this homework. Again, now that I have the same base, I can get rid of them and set the exponents equal to each other. So I get 4, 2x plus 5 equals -2x. So I get 8x plus 20 equals -2x. I'm going to subtract 8x on both sides. And I get 20 equals -10x. X equals -2. Let's just check that. That would be 81. -4 plus 5 equals 1/3 to the -4th. All right, does 81 to the 1st equal 1/3 to the -4th? To change the -4 to a +4, I would make this, I would flip the fraction, right, and be 3/1 to now the positive, right? Okay, and does 3 to the 4th equal 81? Yes, it does. This is my answer. All right, for 18, this is a little bit different because on the the left side of my equation, I have two terms, right? How could we combine them? Well, luckily for us, they both already have the same base, which means if you have like bases and you are multiplying, right, what do we do with the exponents? If we have like bases and we're multiplying, what do we do with the exponents? Hopefully everybody's saying this together, right? You're going to add the exponents. Okay, and then on the other side, let's rewrite this guy with base 9, right? How can we write 1/81 with base 9? Well, first off, I know that, right, 9 squared is 81. And then how could I write that not as a fraction? Well, if it's a +2 on the bottom, if I make it a -2, right, it comes to the top, or that's just my whole number. So I have 9 9 to the negative 2 on the right side. All right, now that they're the same, I'll just go back to black here. All right, same base, I can just set the exponents equal to each other. Right, combine like terms, I get 4x plus 4 with negative 2, subtract 4 on both sides, I get 4x equals negative 6, x equals negative 3 over 2, right, because I just simplified that fraction. All right, if we go back and check our work, 9 raised to the negative 3 plus 4 equal, times 9 raised to the negative 3 equals 1 over 81. Like bases, if we add, right, we get 9 to the first and negative third. Okay, if we have like bases, we can add the exponents. So I get 9 to the negative second equals 1 over 81, right? We already knew that from up here, right? So that is good. That is our answer. We're done. All right, last one for today, because this one looks kind of difficult, even though it's not. Okay. I see a base 4, I see a 16, I see a base 4. All right, hopefully that to you is like, oh, okay, I just need to make them all base 4 because I know that 16 can be rewritten with base 4, right? I can rewrite 16 as 4 squared. So my first term, right, I'm just going to keep. Second term, right, 1 over 16 is, I'll just do this off to the side here. Right, 1 over 16 can be written as 1 over 4 squared, which is 4 to the negative second, right? Then on the right side, right, it's already in base 4, so I don't really have to mess with it, okay? Again, I have like bases, and I'm multiplying. What do I do with the exponents? I add them. However, if you're adding 2x and negative 2, right, they are unlike terms, so you just have to leave it like that. And on the right side, there we go. All right, like bases, I can get rid of them, set the exponents equal to each other. Right, now I need to subtract 2x on both sides. All right, subtract 18 on both sides. And I get x equals negative 5, all right? Let's just go back and check our answer. See, that wasn't so bad. Let's just go back and check our answer. If I'm putting negative 5 back in for x, does it make sense? Let's change to green here. I would get 4 raised to the negative 10 times 1 over 16 equals 4 raised to the negative 30 plus 18. Let's see. So I get 4 to the negative 10 times 4. Again, 1 over 16 is just 4 to the negative 2. Does that equal 4 to the negative 12? Yes, it does, right? Like bases, we had the exponent, so I get 4 to the negative 12. Does that equal 4 to the negative 12, right? We're good. That is my answer.